Okay, so we're recording. Okay, all right. Okay, so let me try this. Okay, so here we go. Okay, so today what we're going to do is I'm going to start with polynomials, okay? Can everyone see this?
Yeah.
Okay, I'm sorry I asked that a lot, but again, I just want to make sure, this is kind of new for me also. Okay, if you have a question, just yell in your microphone or whatever, so. Okay. Anyway, so today what we're going to do is we're going to see what polynomials are. They're actually very, very important. Okay. And it's kind of annoying because what the book does is the book actually, this is actually section P3 in the textbook. And really, I don't like that because what the book does is chapter P, like P1, P2, and so on. The book regards that as review, but I'm not going to treat this as review though. In other words, here, what I'm going to do is I'm going to go at a little bit of a slower pace and do more examples. What I'm hoping to do, if not today, then maybe next time, maybe what I'll do is I'll post a worksheet, like, during this class, or I'll share a worksheet with everyone and then have everyone try it out. Does that make sense?
Yeah.
Okay. We'll give it a shot. Again, I know the technology can be a bit of a pain, but we'll give it a shot though. But anyway, we're going to see what a polynomial is. Not only that, there's a lot of things with polynomials we can do. For instance, we can add and subtract them. We're going to see how to do that today. And maybe not today, at least I don't expect to today, we will see how to multiply them as well. What I'm actually going to show you is I'm going to show you different ways of adding and subtracting. I'm also going to show you when we do multiplication. I'm also going to show you different ways how to multiply polynomials. Okay? And you might be thinking, what about division? Well, in the book later on, they do division of polynomials. It's actually fun, and you do get some nice results. It is complicated. What we might do later on is a special case called synthetic division, which is really actually very neat, and it's a special case. But if we have time, we'll get to that. In the past, I haven't been able to cover that, but I'm hoping we'll get to it though. Okay, so let's get started. And of course, we need some terminology, right? In order to really understand polynomials, we first have to understand their pieces, so to say, which are their monomials. And a monomial is, as you can see here, it's a term of this form, a times x to the k. And again, we're working in the variable x. So a monomial in the variable x looks like this, where the a here, okay, this is the coefficient. A is a constant. It's a number. It's a fixed number, 1, 2, 50, a billion, whatever, but it's a fixed number. The k, the exponent, right? That is a non-negative integer. I mean, theoretically, it could be 0, or, excuse me, it could be 0 positive, but you're not going to see something like x to the negative 1, x to the negative 2. You're not going to see that in a polynomial. Okay. All right. Also, as you can see here, let me just see. Okay. If the coefficient, the a here, right, if that's not 0, this k is given a special name. Actually, not the k, excuse me. The monomial is said to be of degree k. So the monomial is said to be of degree k if a is not 0. Now, if k happens to be 0 and a is not 0, then it's degree 0. And that's really what I'm trying to say over here. So if you have a non-zero number as your, and there's no variable here, then it has degree 0. as a way to remember what I just said, you could think of x to the 0 as 1. Although, as I wrote here, it's really not that precise, because remember, last time I said that 0 to the 0 is not defined, and x does represent a real number. I mean, it is a variable, so the actual number it is could be anything, theoretically. But for now, we can think of x to the 0 as 1. It's sort of like a little convention, and it will come up again, this little convention, when we actually get to really fun stuff, factoring. And you're going to love that. At least I will. But anyway, a non-zero real constant is a polynomial, excuse me, a monomial of degree 0. Now, if a happens to be 0, well, then this whole thing is 0, right? 0 times anything is 0. And by definition, that monomial has no degree then. So then it has no degree. It doesn't even have degree. It has no degree. Now, I used to know why the degree in that case is undefined. But off the top, I used to know that is when I was in grad school in math, and they do have a reason for it, but for now, just think of it as part of the definition. I think it comes up when you do something called group theory, but that's a different story. Okay, so that's what monomials are. So let me just stop this for a second. Are there any questions so far?
No.
No? Is everyone, okay, so everyone is with me, I'm not going too fast?
Mm-hmm.
Okay, so I'm assuming I'm not going too fast then. Okay, so that's what a monomial is. Okay, now let's get to some examples. Let me keep playing this. Okay, so here's some easy examples. So for instance, 3 times x, right? That is a monomial of degree 1. Remember, it's just like with numbers. When the exponent is 1, we don't write it. So here, let me get that laser pointer again. There we go. So when the exponent is 1, we don't write it. So when you see x alone, right, 3 times x, for instance, we have a monomial of degree 1. And of course, the coefficient here is 3. Now, here, 5, this is a monomial of degree 0. And there's really nothing special about 5 here. This could be any non-zero number. Also, with x, when you just have x alone, yes, it's of degree 1, but the coefficient here is 1 as well. So if the coefficient is 1, we do not write it. And again, this is a monomial of degree 1. Okay, that's just, okay, so now let's do some other stuff. Okay, so those are some examples of monomials. All right, now we're going to look at some important information regarding them. Namely, we have this concept here of like terms. And by definition, it's really pretty easy to see that 2 monomials in the same variable and of the same degree, like terms. So in other words, 2 monomials in the same variable. For us, they're really going to be in the same variable x. That's really not going to be too big an issue in this class. Although you could consider monomials in different variables like x, y, z, whatever. For us, we're mostly going to stick with x. But they also have to be of the same degree. So the power of x, or excuse me, the exponent of x has to be the same as well. So those then are called like terms. And if they're not like terms, we say they're terms. Okay, that's cool. Well, so why do we care? Well, it turns out like terms, you can add and subtract. And really, it's not that hard to do, actually. You just follow these rules here. In other words, you just add the coefficients together. or subtract the coefficients together if they're like terms, right? These are like terms, right? The powers of x are the same. If the powers of x were not the same, so if this was m and this was something else, say, I don't know, n, n is a Nancy, then you couldn't combine them because they're not like terms. Okay, good. Okay. Okay. Also notice this, that when we add or subtract, do you see how the exponent is not changing, right? It's staying the same, as you can see. I've seen students when they add or subtract, they would also change the exponent. For instance, here they might put 2m, or if they're subtracting, they might put the exponent as 0, so then the x's go away. What I'm saying is don't do that. When you add or subtract, the exponent of x, the degree, doesn't change. That's what happens with monomials. Okay, that's fun. Well, let's do some examples. So for instance, if you go back, if you look at x and 4 times x, right? Well, these are like terms, aren't they? How do we know that? They're in the same variable. The exponent of x, these are the same, right? They're both 1. So both of these are degree 1. Now, as I just said, we have x is the same as 1 times x, right? Because the coefficient of 1 we don't write. So we get 1x plus 4x, right? We add the wonderful coefficients together, and we get 5x, right? The degree the degree does not change. The exponent of x, leave it alone. Good. Now, what if we had 1 plus 5x? Well, are these like terms? Well, right? What's the degree of 1? Can someone tell me?
0.
0. Awesome. Very good. 5x, the degree is 1. It's like terms, right? So we cannot combine these. Leave it alone. What about this one? Well, this is fun, right? Here we have 2x cubed and 10x cubed. Now these are like terms, right? Difference? Well, we just subtract the coefficients since they're like terms. Doing so, we get minus 8x cubed. Minus 8x cubed. Okay? 5x squared, well, 5x squared and minus 8x cubed, right? Those are not like terms. Those are not like terms. So because of that, we just leave them alone. We can't combine them. Okay. Let me just pause this. Not stop the recording, I mean, but let me just ask this. All right. Are there any questions at all? Guess I'll take that as a no. Here, let me hide this. There we go. Okay. All right, so I just want to make sure everyone's with me so far, so let me keep going, okay? Okay. Okay. All right, so now we get the polynomials. So this is what a polynomial is, okay? As you can see, you're just basically adding a bunch of monomials together. That's all a polynomial is, right? What do you call it, the prefix here? Poly meaning many,